Guncotton is also known as nitrocellulose. Nitrocellulose is cellulose cotton chemically modified by nitration with nitric and sulfuric acid. The OH groups are converted into nitrate groups, ONO2. Thanks to the oxygen incorporated in the nitrate groups, it burns quickly without solid residues, but it must be thoroughly washed and stabilized to avoid degradation and instability. To show you, this is how normal cotton burns. Pretty boring, right? This instead is how nitrated cotton burns. Did you see the difference? Now let's show you how it's made. This is what we'll need: nitric acid and sulfuric acid to make our nitration bath. We'll then need cotton, which is mainly cellulose. The first thing to do was to make an ice bath to cool down the mixture. This was important because the reaction that will occur is going to be exothermic. First of all, I put ice in an ice crusher and I started crushing it. I then put a crystallizing dish on my heating plate and put some crushed ice in it. I then put a beaker in the ice. What we're going to do now is to make a nitration bath to nitrate our cotton. I'm going to explain how this works later. In a smaller beaker, I measured about 60 milliliters of sulfuric acid drain cleaner. I poured the sulfuric acid into the beaker in the ice. I added a stirring bar to the acid and started stirring. I then measured about 60 milliliters of nitric acid and very slowly added it to the sulfuric acid. It is important to do this slowly because the reaction is going to generate a lot of heat. Because of this, I added a thermometer to monitor the temperature. It is also important to mention that all of this process was made in a fume hood. I also progressively added more and more ice. When I added all of the nitric acid, all of the ice was melted, so I changed it for some fresh new ice. I then added some cotton and let it soak in acid for about 1 hour. Now let's explain what's going on here. A nitration bath is a highly acidic mixture, mainly composed of nitric acid and sulfuric acid, used to introduce nitro groups, NO2, into molecules. Its purpose is not simply to mix two acids, but to create an extremely acidic and dehydrating environment capable of generating the truly reactive species, the nitronium ion, NO2+. When nitric acid and sulfuric acid are mixed, sulfuric acid, being stronger, protonates nitric acid. This leads to the loss of water and the formation of the nitronium ion. Sulfuric acid absorbs the water produced, preventing the reaction from reversing and keeping the medium strongly dehydrating. The nitronium ion is a very powerful electrophile and is the actual nitrating agent. If cotton is immersed in the nitration bath, the substance being treated is cellulose, a polymer rich in OH groups. The nitronium ion reacts with these hydroxyl groups, converting them into nitrate ester groups, ONO2. Water is formed during the reaction, but sulfuric acid removes it, allowing nitration to proceed efficiently. The number of nitrate groups formed depends on acid concentration, temperature, and contact time. Partial nitration produces materials used in coatings and plastics, while extensive nitration yields high-energy nitrocellulose. In summary, the nitration bath generates nitronium ions that convert the OH groups of cellulose into nitrate groups, profoundly changing the material's properties. Now that 1 hour has passed, I took the nitrated cotton with 2 stirring rods and put in some water. I added sodium carbonate to neutralize the acids and washed them under tap water. I put the nitrated cotton in a dish and added them in a drying chamber with some drying agents. After drying it, this is what I obtained. If you enjoyed this video and want to see more chemistry like this, consider leaving a like and subscribing to the channel. If you want to leave a comment, it would be very appreciated. Thanks for watching, and I'll see you in the next experiment.